Hey, have you checked out our clone of the Wordle game? We've put it on our website as well. The link for the website is in the description. It is a completely playable Wordle clone game. Alright, that being said, let's build on that and let's create a Wordle solver. This is what I was talking about. This is a completely playable Wordle clone. Let's start with a guess. This is my favorite word to try because it has so many vowels. Maybe that's not a word. All right. I'm just going to go ahead and embarrass myself by giving all the wrong guesses. All right, so there's I and T. Maybe there is tiger. Oh, all right. So yeah, so we'll get close. But you can see that we have made several improvements since we have developed this last week. One of the things that we have done is every time I type in a key, you can see that the key on the virtual keyboard highlights for just a little bit, or it flickers and it shows that, or gives you that visual feedback. All right, and once you get a word right, let's say I put in fight, for example, you can see that the highlight is not immediate, but it takes some time to highlight, sort of adding a visual flair to the whole thing. It also fixes a couple of very important bugs that we inadvertently introduced when we were developing this last week. Let's talk about those bugs in just a little bit, and then we'll continue with the word solver. Let's take this situation for example. Let's say that the puzzle word is the word super, and we have guessed the word chess. How would this word now be highlighted? C and H would be highlighted gray, and the reason for that is because they don't appear anywhere in the puzzle word. E, of course, would be highlighted yellow, and the reason for that is because even though it's somewhere on the word, it's not at the right place. The same will go for the next S, because it's somewhere on the word, but it's not on the right place. But what happens to the next S? How should that be colored? Technically speaking, this should be colored gray. Let's see how I have fixed this in the code. In the code, before I perform any checks on the puzzle word, I create a clone of it because I'm going to be manipulating it. Every time I find that the letter is in the right place or is the right letter but in the wrong place, I simply remove that letter from that clone word. And the reason for that is that once I have removed it, it won't get matched again. This is in fact what is happening. Let's take the situation where the letter S has now been matched with the puzzle word. If it finds a match, it highlights it yellow, but what is also happening is that the letter S is now removed from the puzzle word. So the next S, when it tries to match with the puzzle word, it cannot find it and would therefore be colored gray, like this. That's in fact what is happening in the code. And that actually represents the major, I would say, bug fix in the Wordle clone itself. All of this code is now available on GitHub for you to download, and you can also sort of play around with this. All right. So I know that last week I said that we are going to be doing this in Python, but since we have already built the Wordle puzzle on JavaScript, let's just continue with JavaScript and build a solver in JavaScript itself. So last week's code and this week's code, all of it would be available on GitHub for you to download, maybe manipulate and build a better Wordle solver. So with that being said, I think I also need to do a couple of explanations as to how we are building this solver. And also, for this to work, I do believe that we will have to work with JavaScript's promise and resolve function. So we'll just briefly look at these two things. How do we go about solving this, and the promise and resolve. So let's just look at these two functions in just a brief before we do the coding part of it. Now we are going to be building a solver. Remember, to build a solver or to actually automatically solve it, you only get 6 tries because that's the number of rows you have, and within 6 tries you'll have to guess the correct puzzle word. So how do we do this? The thing I had in mind was to build a function that would first pick a random word from the list of remaining words. All right, don't be thrown off by the remaining words terminology that I'm using over here. You'll see why in a moment. All right. So what I'll do is I'll pick a random word from a list of all the 5-letter words. Then we will guess that word. We'll say, this is the word I'm going to submit. What the Wordle game would do is it would highlight it in gray, yellow, or green. After that, I will start filtering out words. And how do I filter them out? First, from the array of 5-letter words, we'll filter out letters that are gray. All right. So if there are gray letters, in the guess, then I'll simply remove all of the words in that huge 5-letter word array that have those gray letters in them. So if they're there anywhere, I'll filter them out. From the remaining array, from whatever is remaining, we'll only keep words that have the letters in yellow. That is basically the words that have the letters present somewhere in them. So if the letters are present somewhere, then we'll keep them. And from the remaining array, from of the previous step, we'll only keep those words that are present in those exact spaces, or basically those green letters. If we have them, we'll only keep those. And as a final step, what we'll do is from the remaining array of the previous step, we'll filter out words that we have already guessed. Now remember, you might think that this should be solved in just one try or so, but it's not like that, because we start with such a huge list of 5-letter words. So what happens is that so with whatever that is remaining, we basically loop through this, and we do all of these steps 6 times. All right. And my guess is that when we do this so many times, it just basically arrives at the solution without any effort. So what will happen is that you'll begin with a huge set of 5-letter words. With every step, those 5-letter words will basically converge onto the solution very quickly. And all we have to do, I think by the 3rd or 4th guess, we would already be down to 3 or 2 words that are actually the solution. So that's what I had in mind. We just have to look at how promise and resolve would work. So let's do the promise and resolve explanation for just a little bit, and then we'll continue and then we'll do the coding part of it. What I have here is a main function in the form of the load event. I have 2 functions, call me and call me to. The call me function just simply prints the big int, and call me to basically says this should be called after the call me function, and that's what I intend to do. What I want to do is I want to call the call me function, wait for 2 seconds, and only then call the call me to function. Let's see this in action and see what happens. So I'll go to the browser and I'll hit refresh, and you will see that it immediately calls the call me to function and only then calls the set timeout. Now we all know how the set timeout works. It waits for these many milliseconds, in this case 2 seconds or 2000 milliseconds, and then calls the call me. But the set timeout doesn't work like the sleep function of C. It doesn't wait for the next, it doesn't wait until it calls the next function in the, in its call out. It'll just immediately pass on the control to the next line, and then it calls the call me to, which basically prints this. So how do we resolve this? One way to resolve this is using promise and resolve. So let's look at that. So I've now changed the function so that I use promises, resolve, and reject. The way a promise works is that it allows you to attach asynchronous resolves. So if you wanted to have a callback and that callback needs to be asynchronous, a promise, resolve, and reject are the best way to do it. A promise is a function with which or on which you can either resolve something or you can reject something. So a promise is a piece of code that you expect to either succeed or not succeed. If it succeeds, then it should call the resolve, in which case what will happen is that on the promise object, you can define a then action, and then you can have the callback done. And this can be completely asynchronous. Now, if you call the reject, now if you do the reject, then it will go to the catch part of the promise itself. All right. So that's how you can basically use the resolve and reject. Now, what I have done over here is I've taken a promise, then I'm calling the call me function, which should print this, and then I say resolve. So the resolve would go to the then, and then it calls the call me to function, and then it sort of prints this one. Let's see this in action and see if this works, right? So if I do this, it'll call the big int, and then it'll call this one after the other. But remember our original premise where we said that the second function should be called a couple of seconds later. So let's add the timeout. This is where the asynchronous part of the resolve works beautifully. So I just say set timeout, and after 2000 milliseconds, you call the resolve. So I'll go back, refresh, and you'll see that it says big int, and it says, after 2 seconds, it prints the other line that we had intended. So that's how a promise and a resolve works. Now remember, the promise and resolves can be nested as well. So you can have one promise and you can have another promise in the resolve function itself. So you can chain these kind of promises, or you can sort of put one promise inside the other so that these things are chained. So now that we have seen how to solve this, what are the steps we are going to solve, and we have seen how the promise and resolve works, let's look at the code. Let's code the solver in and see where it goes. We'll start with what we completed last week. This includes all the bug fixes and flares that we added to the Wordle game. So when I look at the Wordle solver, you will see that the project is exactly the way that we completed it last week. We'll sort of build the solver on top of this. What we'll do is we'll introduce a file called Wordle solver.js. We'll leave it empty for now, and we'll simply include this Wordle solver inside our main HTML file. So let me just put the Wordle solver over here, and what we'll do, and what I intend to do over here, is to ensure that the Wordle solver is independent of all of the files that we have done yesterday. So the Wordle solver essentially should not peek into what the puzzle word is. It should not know what the puzzle word is. It should use all of the existing functions that we have written. It can use them, but it should not sort of peek into what the puzzle word is. It should solve it by itself. We'll take that step by step. That being said, the only thing that I'm going to be using from last week is the list of 5-letter words. So this, I really don't have any other go, but I will have to use the 5-letter array that we created and sort of filter down or go from there. So let's begin with our first piece of code. Let's just take a note of what we are going to do when we are coding this. The auto solver that we are going to build is automatically going to fill in the words in these puzzle cells. It will also check if the word has been solved or not, and then proceed to the next row automatically. That's the intention I have. All right, so with that in mind, let's begin the coding. We'll start by declaring a variable that will hold the value of the row that we are trying to solve. The total number of guesses we get are just 6. We'll also create a clone of the 5-letter word array. The 5-letter word array was coded as part of last week's episode. We are using JavaScript's ES6 clone method to clone this array. We'll set the current row to 0, and we'll call a function called solve step. This function will contain the code to filter out our words. Now, if the current row is already at the end, then that's the end of this solving, and we will exit our solver. All right, so what did that do? Let's go to our browser, hit refresh, and let's call the solve function. It does nothing, and the reason for that is because we've not basically done anything. We've not guessed a word, we've not done anything. So as our next step, let's try and start with guessing a word. Now this isn't that difficult. We'll simply define a function called pickRandomSolution. We'll create a loop, and we'll pick a random solution from the list of available words. In the loop, we'll ensure that the word doesn't have any duplicate letters or is plural. Both these functions were defined last week. In the solve step, we'll first console log the number of words we have left to guess from, and then we'll invoke our random solution picker function and log the solution word. Hopefully that worked. Let's go back to our browser, hit refresh, and call the solve method. So there are errors, when isn't there an error when I'm typing? The issue we are having is that it says array of words is not an array. I mean, it's not a function. Of course, it's not a function, but I've used it as a function. That's one issue. And the other is I've said word is plural. It's not plural, it's plural. All right, so now that I have fixed those two, let's go back over here. Let's call the solve. All we are doing is making a guess. All I want to do is make a guess. And the next step is I want this auto solver to automatically start filling out these letters. All right, so let's do that. Now to fill it automatically in the puzzle cells, all I have to do is loop through our solution word character by character and then call the add character function. This was defined last week. This will automatically type the character onto the screen. I'm doing this in a set timeout because I want there to be a delay between typing one letter and the next. Let's look at the result of that. Let's go back, hit refresh, and call the solve function. What this will do first is it will make a random guess. It will guess It's guessed flyer over here. And if you've noticed, you'll see that it sort of started typing out one after the other. And the reason why it took such a time to fill out everything is because of the set timeout magic that we've done. So it essentially calls the add character and the depress key after this timeout. The timeout sort of builds for every character that is there in the word. So not only have we called the add character that sort of adds the character to the current row, but it also depresses the key, giving you the illusion of it being typed automatically. So let's call the solve again and you can see what happened over here. So the next step for us is to simulate the enter key. Now, if you remember from last week, we had a function called row complete in our Wordle puzzle. So we'll call the row complete, and that row complete will check this word for its correctness. So basically it will convert, or it will tell us if the letter is either black, yellow, or green. It'll do that automatically once we call the row complete. So let's do that. Now we just finished typing out the letters on the screen. The autosolver now is able to type out the letters. Now what we would expect to happen is that the row complete gets called, which sort of presses the enter key, which sort of simulates pressing the enter key. And once we know the solution, or once we know what the state of that current word is, we filter out the grays, we keep the yellows, and then we keep the greens. All right, this is what we expect to happen. But keep in mind that when you type out the letters, it takes time for all of the letters for the word to appear, because that's how we've built the game. So we should have some sort of timeout mechanism before we call the row complete. And not just that, the row complete also takes time because it needs to color the words and because it puts in the colors. And then there is a significant amount of delay between you calling the row complete function and it actually completing it. Now you would expect that, this is one after the other, but you'll have to sort of wait. And because we are not going to touch the original code that we wrote the other day, we'll have to sort of work around that, or work around what we have already built. So what should happen is that when you type out the letters, it should wait before you call the row complete. When it calls the row complete, you should wait before you call the other functions. The other functions, they can be completely synchronous. That doesn't matter, but you'll have to wait before it calls the filter grays, before it calls the various filter functions. And the way we'll do it is using the promise and the resolve. And this is what we are going to do. Now, I've tried my very best to sort of give an explanation as to how this will work. We will work with two nested promises. I'm calling this the promise outer and the promise inner. Now the promise outer itself will call an inner promise that will call the row complete. Now this one will wait for some time, a fixed amount of time before it resolves the outer promise. Now once it calls the resolve outer, it goes to the resolve of the outer and then it calls the filter functions. This is where you would basically filter out all the words and you would check to see if you have already solved it. That's the explanation part of it. I'm hoping that the coding is actually easier than this. So let's get to that. We'll set up an outer promise, which itself has an inner promise. The inner promise is where we invoke the row complete. The row complete needs to be on a timeout so as to allow the characters to be typed out first. Once done, it will also call the resolve of the inner promise. That in turn calls the resolve of the outer promise after a timeout. In the resolve of the outer promise is where our main code to filter out words will go in. It will also increment the current row and will check if the game has been won. Now, if the game has not been won, it will simply call the solve step after a timeout of 1.5 seconds. If there are no errors, this should work. All right, let's Control F5 so that we do a proper refresh. Then I'll call the solve function. You can see that it types the first word, waits for some time, resolves it, and then goes on to the next word. Each time it guesses a word, you can see that the number of words that are remaining has not yet reduced because we've not done any filtering or anything like that. But you can see that it sort of automatically plays all of the letters that it has, or it guesses the next word and then it goes on and on, to the next word. So all we have to do now is write the filter functions. So let's write the filter functions to filter out blacks, yellows, and greens. And I think we should have a proper solver in our hands. Now this is where all the magic will happen. We'll start by defining the 4 functions needed to filter out the words. First, we'll define a function to filter out the gray letters. This is actually very straightforward. We'll loop through the columns of the current row and we'll get the puzzle cell at that row and column. Now we'll check for the existence of the style that makes it gray. In this case, it's the not present style. If the style is found, we'll know that the letter cannot be in the list of our words. All we have to do now is filter out the array of words such that it has no words where the letter is present. Next, we'll write the function to keep only those words that have the yellow letters in them. We are doing this in exactly the same way as our grays function, except we'll only keep those letters instead of excluding them. We'll do this, of course, by looking for the right letter style. Next, we'll write the function to keep only those words that have the green letters in them. We'll do this by looking for the right place style. In all the 3 functions, we are using the ES6 filter method. This is JavaScript's filter method. Let's invoke the next 3 functions from our final resolve block. And finally, we also have to filter out the words that we have already guessed. This is so that we don't guess the same word twice. Okay, so we've defined all the filter functions and called them one after the other in our resolve function. The one bug that I had discovered was that I had called this variable as close instead of calls, and I think it was an autocorrect thing, but anyways, it should be called calls. Let's look at the result. I'll refresh and I'll call the solve function here. Look at how many words are filtered out each guess. That's how effective the filters are. Remember that each guess starts out with so many words but filters out so many along the way until it is left with just a few words to randomly pick from. Look at this. This has already solved, or it has gotten the result as agony. All right, so basically at this point it was just left with 2 words. Let's refresh, clear the console and call the solve once again to try another thing, right? Oh wow, these many words left. Okay, that's good. 18 words left. 1 word left, and I think that's it. All right, so 4 out of 6. I think that's a very good score. Okay, so I think we are done with the automatic Wordle solving. I'll say my goodbyes. I'll show my face, and I think that's about it. So I've modified the HTML page so that there is a smiley button over here. When you click the smiley, it will solve the puzzle. So let's click the smiley. This is actually a good start, not too bad. This is better. All right. Okay. Oh, come on. So on the 6th try, it actually did get it. Now, I'm pretty sure the smarter ones among you might already be thinking, maybe when you pick out a word, which is at the right, which is there in the word, but not at the right place, you can make sure that the next guess that you make, you don't pick out the place, you don't pick out the letter in the same place. There are several things that you could do to, of course, improve this. But just for posterity's sake, I'm going to refresh and I'm going to click on the smiley once again, just to sort of see it solve it by itself. I'm not too smart at solving the Wordle puzzle, so I've basically, oh, there you go. 3 out of 6. This is actually an excellent score. So that's about what I had for this week. Thank you so much for joining. All of this and everything would be hosted on our website, and I'll leave the links to all of them on the description. If you want to play this without the auto guess, you can play last week's episode. And if you want to have a look at the auto solver, you can play around with this week's episode. So thank you so much for joining. This was the Big Int. See you next week. Bye.